Hi guys. So we're going to be doing exponents and sets. Um, so exponents and sets. So before we get into more details, let us talk about the number system. This is part of the number system. As you can see, there is this huge cycle here is showing us real numbers. Um, this segment of the cycle is real numbers, and this side is non-real numbers. And non-real numbers are imaginary numbers, numbers that don't actually exist. Um, these are numbers such as the um, the the square root of negative numbers, and so on and so on and so on. So square root of negative numbers fall under here. And then in real numbers, they are divided into two, rational and irrational numbers. And now irrational numbers, we'll talk about them on the other slides, as well as rational numbers. But then under rational numbers, we have integers, we have whole numbers, and we have natural numbers. I'm going to explain them more and more in detail. Right. So this is the number system. We have natural numbers, like I said. So natural numbers are 1, 2, 3. So these are numbers that occur in nature. And then when we talk about whole numbers represented by NO, this O simply means now we have included the O. So it's basically natural numbers, but now we have included the O, and those are whole numbers. And whole numbers themselves are whole numbers themselves are 0, 1, 2, and 3, and so on and so on and so on. Then we have integers. So integers start from negative infinity to positive infinity, and they include the 0. And then, so what you can remember is that, oh, natural numbers don't have a 0. Whole numbers have a 0. So natural numbers, positive numbers without the 0. Whole numbers start from 0 to positive numbers, and the negative and the integers start from negative infinity to positive infinity. And, and then rational numbers are numbers which can be written as this, as a over b. And what do we mean they can be written as a over b? We mean when we say they can be written as a over b, we mean that when we say they can be written as a over b, where a and b are integers and b is not 0. Okay, what do we mean? The reason why it's q, right, is because this q stands for quotient. So it's quotient numbers, so they can be written in quotient. Remember that in a quotient is an answer you get it's an answer you get when you divide. So what kind of quotient are we talking about? We are talking about um, an integer of an integer, a over b, where a and b are both integers, so they are element of z, but then b is not 0. Reason being, if it is 0, then this number is going to be undefined. And then we say, okay, rational numbers can also be written as a terminating or recurring decimal number. For example, 0.5, 0.43, 0. So it's not something like 0.34373 da. So they have to either be recurring or they have to be terminating. For example, 1 over 3. 1 over 3 can be written as 0.333333333. So that's recurring. And then it should be terminating, like I said, like 0.4. So it shouldn't be a complex number like pi 3.14 and so on 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 and so on. That is not a rational number. All right. And then we have examples here, minus 7 over 2, that's an example of rational numbers. Minus 2.25, rational number. 0 is a rational number. Square root of 9 is a rational number. 0, 8, there. This dot on top of the 8 here, it says, it shows us that a number is recurring. So that's a recurring, and then we have 23 over 1. That's also a rational number. Right. Now, we have irrational numbers, and irrational numbers are numbers that cannot be written as a fraction. So they can never be written as a fraction with the numerator and denominator as integers. So they cannot be written as rational numbers, basically. Irrational simply meaning the opposite of rational. And irrational numbers also include decimal numbers that neither terminate nor recur. So they don't terminate and they don't recur. And then we're given example as root 3. Root 3 is irrational. You can never write this as a fraction. And then when you write this as a decimal, it doesn't terminate and it doesn't recur. The fifth root of 2, we have pi, like I made an example before. We have 1 plus root 5 over 2 and 1.27548, and so on and so on and so on and so on. So you can then definitely see that this is an irrational numbers. Then we have real numbers, and like I said before, real numbers include rational and irrational numbers. And then we have non-real numbers, and these are imaginary numbers, and they are numbers that are not real. Example, root of minus 25, the fourth root of minus 1, minus of the square root of minus 1 over 16.